Hey everyone, and welcome to this explainer. Today we're going to put on our site reliability engineer hats and tackle one of the absolute most critical aspects of running modern applications, and that's observability. We're doing a deep dive into Kubernetes monitoring, and specifically, we're going to demystify Prometheus. If you've ever wondered how SREs manage to keep wildly complex, cloud-native systems running smoothly 24/7 without completely losing their minds, well, you're in the right place. We're going to break down the exact tools and concepts used in production environments today, and we'll do it step by step so it all makes perfect sense.
Here's a quick look at our roadmap. We'll start with 1. Metrics versus monitoring, then move to 2. Measuring IT system health, 3. The Prometheus architecture, 4. Exporters and gathering data, and we'll wrap up with 5. Dashboards and effective alerting. Let's get right into it.
Okay, let's dive into this with Section 1, Metrics versus Monitoring.
You know, a lot of folks use the words metrics and monitoring interchangeably, but they are actually very different things. To picture this, imagine a patient in the hospital. A nurse coming in and writing down a heartbeat of 76 on a clipboard every 15 minutes. Those are metrics. It's just raw historical data. But if that heartbeat suddenly drops, a clipboard definitely isn't going to alert anyone. A monitoring system, on the other hand, is the actual machine hooked up to the patient. It visualizes that metric continuously and sounds a loud alarm when things go wrong. Monitoring is what makes your raw metrics actionable.
So the crucial point to remember is that metrics are simply the foundational, historical data of events. They are absolutely essential for understanding the health of a system, but on their own, they're basically just a massive, unreadable spreadsheet of numbers. Imagine staring at thousands of heartbeat recordings in an Excel sheet and trying to spot a minor anomaly. You'd completely miss it, or honestly just go cross-eyed trying. Metrics give us the raw facts, but we need a monitoring system sitting on top of them to actually make sense of those facts and keep us from having critical operational blind spots.
Moving right along to Section 2, Measuring IT System Health. Let's map that hospital analogy over to a real-world AWS Kubernetes cluster. As SREs, we track vital signs across 3 critical layers, because if even one of these layers gets sick, your application is going down. First up, the infrastructure layer. These are your actual virtual machines or Kubernetes nodes. Here, we're tracking historical info like node CPU and memory utilization. Second, the Kubernetes cluster layer. We look at pod status. Did a pod just go into a crash loop backoff? How many deployment replicas are actually running right now? And third is the application layer itself. Are your users experiencing errors? We track total HTTP requests, user signups, and even account deactivations. Depending on the size of the company, an SRE might collect 10 of these metrics, or they might collect hundreds just to truly understand their system's health.
All right, Section 3, the Prometheus architecture.
So how do we actually collect all this data? Well, we use Prometheus, which is the CNCF-backed industry standard for Kubernetes monitoring. Now, at the absolute heart of Prometheus is a time series database, or TSDB. Why does time matter so much? Think back to our hospital patient. A heartbeat of 60 is totally fine while they're sleeping, but maybe not so great during a treadmill stress test. The context of time is literally everything. A time series database stores metrics by pairing key-value data, like a server's CPU load, with an exact, highly specific timestamp. So it records that at precisely 10 a.m. and 6 seconds, the CPU utilization was exactly 81%. This is what allows Prometheus to build a flawless historical timeline of your entire system's health.
Which brings us to Section 4, Exporters and Gathering Data.
Okay, so you have all these layers generating absolute mountains of metrics. How does Prometheus actually ingest all of it? It uses a really efficient pull mechanism. In SRE terms, we call this scraping. Step 1. Little add-ons or plugins called exporters constantly gather the system data locally. Step 2. The retrieval component of the Prometheus server actively reaches out and scrapes, or pulls, this data from those exporters at regular intervals. And Step 3. It securely stores all that rich information right into the time series database we just talked about.
But hold on a second. Think about a large, highly dynamic Kubernetes environment. You might have 100 different applications running, spinning up and scaling down constantly. So I have a question for you. Out of those 100 applications, how does Prometheus know exactly which endpoints it's supposed to scrape at any given second? If you were managing this manually with static configurations, you'd be updating files all day and pulling your hair out every single time a pod scales.
The answer to that headache is a brilliant concept called service discovery. Instead of relying on static configuration targets, where some poor human has to hard code every single IP address, which, let's be real, is impossible in a dynamic cloud, service discovery acts as a smart routing system. It dynamically communicates with the cluster to tell Prometheus exactly which specific targets and application endpoints currently exist and need to be scraped. It completely automates the entire targeting process for you.
And this brilliantly illustrates the three primary ways Prometheus gets its data from the cluster. The node exporter talks directly to your virtual machines for hardware metrics like CPU and disk space. Meanwhile, KubeState Metrics is continuously pulling the Kubernetes API server to monitor things like pod statuses and your deployment replicas. Finally, the developers can expose application-level data, stuff like HTTP request counts, directly right in their code via a /metrics endpoint. Prometheus is constantly pulling from all three of these sources simultaneously, so you literally never miss a beat.
Finally, let's wrap up with Section 5, Dashboards and Effective Alerting.
Okay, so we've successfully gathered millions of data points into our time series database. But let's be honest, staring at raw numbers is terrible. To actually visualize this data, Prometheus is almost always paired with Grafana, forming an incredibly powerful monitoring stack. Grafana connects directly to Prometheus as a data source. It uses Prometheus's custom query language, which is called PromQL, to pull the exact data you want over a specific time period. Grafana then takes that raw time series data and transforms it into the rich, highly readable pie charts and line graphs that DevOps teams rely on to spot trends and traffic spikes instantly.
But here's the catch. We also need alarms for when things go wrong and no one happens to be staring at the Grafana dashboard. This is where Prometheus's Alert Manager component comes in. Here are some real battle-tested alerting roles an SRE might configure. You can fire an alert to the team's Slack if a node CPU goes above 80%, or send a message if disk utilization exceeds 75%. You can even get highly specific, like firing an alert straight to the dev team if an HTTP request processing latency of 10 seconds is seen 30 times in a single day. Alert Manager catches that system degradation and notifies you way before your users ever notice an outage, though ideally it doesn't page you at 3 a.m. on a Sunday unless it's truly a critical emergency.
So, we have covered a ton of ground in this explainer today, from the core differences between raw metrics and active monitoring to how Prometheus actually uses exporters, service discovery, and that time series database to scrape and store system health data, and finally how we visualize all of it with Grafana and set up alerts for the team. I want to leave you with this final, somewhat provocative thought. If your critical system suddenly crashed right now, is your monitoring doctor ready to page you instantly, or are you still just relying on an unreadable spreadsheet of raw metrics? Think about it. Thanks so much for joining me on this explainer, and keep building those resilient systems.